points, MP, melting points, solids only. I'll try to take the melting point of a liquid. Already happened. You may want to do 2 melting points and even 2 boiling points. Why do I say that? I say that because you got no idea on this one. You know, normally you got some idea of where this thing should be melting. This one you got no idea. So I would do a fast one to find out the range, you know, maybe even like a 20-degree range of where it roughly happens, and then do a second one, more careful one. Okay. The trick for these fancy ones, these black ones with the arm like that, right in front of Shelby, it's the other one, right, and the other one's right in front of Gina. The trick with that is, if you want to do it fast, you set your target for like 250 degrees. Okay, that should cover all of them. 250 degrees. And you do 10 degrees per minute. So you're flying up, you get an idea of the range. Okay? When you want to do a careful one, that's a little bit tough. Let's say your melting point range is from 120 to 135. Okay? It's in there someplace. Now, how do we do it carefully? You don't want to do 1 degree per minute starting from room temperature. Okay? Because that's going to take forever. It'll take 130 or 110 minutes to get up there. Okay? So what you do, does everybody remember this? I'm sure I've said this at some point during the year. What you can do is set it for 10 degrees per minute until you get to like, you know, if the range starts at 120, I would stop it right at 105, about 15 degrees below your range, and turn off the machine. And turn it right back on. It will still be at 105 degrees. Now reset it, hey, do it 1 degree per minute. And it'll start roughly at 105 and then do 1 degree per minute. You'll get a sweet, perfect melting point. Sound good? Beautiful. So I may want to do 2, first fast and then a careful. All right. Also today, aqueous solubility. Yeah. Just like it's done in the book. Page 462. 463. Okay, maybe that's not what the flow chart is for aqueous solubility. Or maybe it is, maybe it's on 462 and then how you do it is it's right around there. Do careful. Plan on 2 times to 3 times doing those aqueous solubilities on each one. Saves you lots of headache, lots of time doing unnecessary qualitative tests. If insoluble, make sure you heat and stir. You can even, when you're doing your aqueous solubility test, I'd already just had a hot water bath setting of about 3, already waiting to go. Okay. You can almost guarantee you're going to need to heat some. In H2SO4, any color change, delta is change, heat, precipitate, or any sign of reaction. Okay? Count that as soluble. Okay? organic solubility. Just do chloroform. Book says chloroform and methanol, but I'll guarantee you they're basically all soluble in methanol, but we do want to know if they're soluble in chloroform. Okay? That's important information. The Beilstein test. What's that for?
Halogens.
What's that? Halogens, yeah? Is that what you said? Yes. Halide. Okay. How does it work? You guys, by the way, are going to have to do a couple of mechanisms in your final report. Okay? This one doesn't count as one of the mechanisms. It's not really a mechanism. It's just a couple reaction steps, reaction balance chemical equations. Okay, so heat copper wire in oxygen that's in the air. And what happens is you're taking copper solid plus O2 gas, and you're turning it into copper oxide. Oops. Yeah. Okay. Two. If halide is present, it displaces the oxygen with copper oxide. Some alkyl halide. And you get copper halide, whatever that particular halide is. Not actually, I've never thought about what the byproduct is. Plus organic byproducts. I should figure that out. This guy, that is volatile, means it becomes gaseous. And burns. What's a positive test? Bright green. This test is usually pretty rock solid. Some of these tests we're going to learn, they can be a little wishy-washy. You're like, whoa, is that a positive test or not? You know, you just got to take as much information as you can. This one's usually pretty good. Okay. And then the ignition test. What's the ignition test for? Students often get this slightly wrong.
Saturation.
What's that?
Unsaturation. Aromaticity.
Aromaticity applies conjugation. Okay? So alternating double bonds, which aromatic is a great example, but you can't actually have conjugation alternating double bonds that's not aromatic. It's not even a ring. So. Alright. No mechanism for that, dude. A couple things before and then I'm going to demonstrate the Beilstein test for you. Okay. Let's say it's soluble in water. Okay. Soluble in water, which means you got to do the pH papers and the litmus papers. Okay. What I always recommend students do is, you know, you're kind of doing doing the solubility tests, trying to add just a little bit of the unknown, okay? If it's soluble in water and you are now trying to decide is this kind of an acidic compound, is it a basic compound, all right, put more unknown in there. Dump some more in there, and another couple of scoops or another couple of drops, okay? So we get a lot in there. If you do both litmus papers, if the blue turns red, it's an acid. Okay, nothing will happen with the red one. All right, so if the blue turns red, you might need to write this down. No. If the blue litmus paper turns red, it's an acid. If the red, and if it's an acid, the red won't do nothing. Okay? If you do the red and it turns blue, so if they do the opposite, then it's the thing. Does that make sense? If the red turns blue, it's an amine. All right? If neither of them turn, you then have a water-soluble neutral compound. So it's the same. Pay attention to everybody to this, because students do miss this part too. If it's water-soluble and doesn't do the thing with either of these things, okay? By the way, you can also confirm that these are really nice actually, because they actually give you a specific pH. If it's somewhere around like 3 or 4, it's carboxylic acid. Somewhere around 11 or 12, it's an amine. Okay, those are nice. But if it doesn't do these, then it's one of the neutral compounds, just like the sulfuric ones. Okay? It's a ketone, it's an aldehyde, it's an alcohol, it's an ester. It's one of those compounds. Okay? It just happens to be soluble in water. That's why you found yourself up here in the flow chart. Does that make sense, guys? Yeah. Yeah. Okay. All right, let's go. Oh. I don't think I have my goggles. I can't do that. Not my goggles. All right, I was going to say, you guys can get going. Oh, first I got to give you my notes. Shelby, pick a number between 1 and